valid TypeScript code. Now, of course, you wouldn't use that in your code if you are creating TypeScript application. You would start directly with TypeScript, but sometimes you need to import libraries that are only available in JavaScript, and you might copy-paste that code and you don't want to convert it. We will not do that. We usually use a better option where we find some mapping between your JavaScript and the TypeScript. TypeScript also, by the name, it supports types. What does it mean to have a type? Can somebody describe what is a typed language? Anyone? No? So a typed language basically is a language where you cannot just define a variable and assign it anything to it. You have to specify what type, what property it has. Like, is it a number? Is it an object? Is it a string? So this is what is behind the typed language. And we will see in a moment what are the benefits of that. One interesting thing in TypeScript is the typed is actually optionally inferred. Inferred means basically TypeScript language can recognize eventually what is the type of your property. Like if you assign to a variable a number, TypeScript will immediately recognize, hey, the type of this property is a number. We will see that in a moment. And it's optional. There is a magic type in TypeScript, which is any, where you can basically assign anything to it. But you don't always want to do that, because you would fall back to the same problem you meet in JavaScript. So the benefit of TypeScript over JavaScript, there are a few that we can actually find with new languages like ES6 and TSLint. We can kind of catch up on the feature with extra plugin on your IDE. You can kind of get towards TypeScript level of support, but there is a few things that is much interesting in TypeScript. It is built in the TSC, the TypeScript compiler, or the feature of your IDE to give you all this power from the feature itself. So the first thing is at compilation time, it can detect errors. Today, most IDE can use this power to actually inform you directly as you type with IntelliSense or other error checking in the code, that you get the feedback immediately that something is wrong. So you can detect typographic error, which is very easy to miss in JavaScript. Actually, how many people do we have here that are using JavaScript intensively? Okay, what are the other languages that we have here? Java? Scala? C#? Do we have COBOL? Okay, good. No, because I have nothing for you. Okay, another thing that is interesting in TypeScript from the type assignment is that when you have a lot of code over your application, when it starts to get a bit complex, it's easy to assign things to the wrong object, and it just appears at the wrong time. Like, for example, we have some code here, so I define a horse, I give it a name, I tell it how to neigh, and I have a function to clone it. It's just basically return the horse with the name. Then I create an instance of the horse named Jim, and we have another instance of dog. So we have a dog with a name, it has a bark function, and a clone function. Now we create a dog instance, Joe equal new dog. This is JavaScript, by the way, just to make the comparison. And then a few hundred lines later, you need to clone your dog because you want a new instance of it. But a few hundred lines later, Jim, you think it's a dog, but actually it's a horse. And that happens when you do the demo, not when you are writing the code. So that's what something TypeScript can protect you. Now, we're going to use, as we go into the lecture, part of it gradually with some small exercise, and then we will play with a real application to look at how we can just build something very quickly. So I talked about the variable types. I already mentioned a few that are very popular in any language. String, number. We have any that is this magic, can put anything into it. And we have a few more. I talked about the inference. So the language infer the type to the property. So when you create, if we go back, well, that was TypeScript, JavaScript. When we create a variable and we assign it a type, we call it inference. We infer the value. And when the language does that, when we have an assignment to the type, but you don't define the type, as I was mentioning, the language is going to apply that type to your property. Now, I think I have a slide missing that shows. So we are going to look at directly in the code with here. Okay, so I'm going to open and show. Let me find the project. Oh, I need to go to. Okay, that's okay. I'm just gonna clone it again. And, okay. Are we looking as Joel or admin? Yeah. Which one? Oh, admin. I'm looking for the. I clone a repo somewhere here. Well, I just clone it, yeah. That's the user administrator TypeScript 30. Oh, okay. There we go. Okay, so I will share this this project in a moment when we start playing with it. Let's go to. Can we see? Is it too dark, or can we see? It's too small. Yeah, I can zoom for this one. Okay. All right, so let's see a bit what I was talking about. So here we have an example of multiple types of variables. By default, when I have not assigned any type to my variable, the language will assume or infer to be any. If I annotate it by myself, it will also get the type that I give. And we have all those examples here for number. So the language and the IDE recognize that this is a number. If I don't assign it, yeah, thanks. If I don't assign the type or annotate the type, it also recognizes it because I'm setting the property. And since it knows that this is a number, as I was saying earlier, if I try to give it a horse, it's going to say, no, you can't put some text because this is a number. Right? So you get that directly as you write code, so you don't have to wait that it explodes in your face when you are doing the demo or running the application. The other type are the popular one like string. We have Boolean. We have arrays. That is two types of notation if we want to use array. The kind of generic one that is popular in many languages that exists in JavaScript. And we have this notation here that is more like object-oriented type, where you define the array and use this generic type of notation with the squares, with the brackets. There is this particular type, which is a tuple. Actually, I don't know how to pronounce tuple, tuple, tuple. I don't know. Somebody can maybe help here. When we use tuple, basically think like dictionary if you're in C# or hash map if you're in a Java style of language. So here we can even compose array of tuple or tuple of tuple. So you can compose any structure of data that will help you to build the model, the data model you need to have in your code. And what is also quite useful is the enum, because sometimes you don't want to have hard-coded constant in your code or static numbers here and there or text. So we have this enum support. And here I'm showing two examples. First one, I let the language, is it still big enough? Yeah. I let the language define what is going to be the number associated to these properties. So with language, I have a Thai, English, and French, and you see the numbers are already associated to follow starting from 0. If I wanted to use an enum to define country code, I can assign the value I want to this enumeration, the same way that you find it in object-oriented languages. So here now my property has the value 66. I can use it in the code to actually set a default prefix to the country code of my in my code. And basically the way you use it is simply calling your enum object and use it, provide the specific enum value that you want to use. Let's forget about that for now. The function below, we will go there in a moment. So this is basically how it looks to declare variable. Any questions so far? Like, if we look at this compared to JavaScript, is there a lot of difference so far?
What's the meaning of let versus var?
Let versus var. Okay, so this is very similar to what we find in ES6, right? Where let is actually scoped, and var is just going through any scope. Like that's one of the main difference. I think there is something here. Yeah, so you are actually ahead, but we will see here what this means when we transpile. And actually, I'm talking about transpiling, compiling TypeScript. Does anybody know what does it mean to transpile or to compile? And actually, what is the difference between compile and transpile? Anyone? So, transpilation. This is actually compilation, because you're all familiar with compilation, right? You compile your Scala code, your Java code into binary code or byte code that is directly executable. But transpilation is more converting a language to another language. Like this is more maybe the closest description we can give to transpilation. But both general meaning is the same, is to convert a programming format to another format, which might be read by a machine or by a human in the case of JavaScript and TypeScript. So here, I think I'm somewhere in the slides, or we can play with that when we are when you get that Git repository. But what happens in the actual converted code for this method? But that's one of the main difference between let and var. Now I need to get back to the slide. Okay, so we have seen tuple, the enum, ambient. Okay, that's an interesting thing. Declare ambient. Sometime you are using a third-party library that has been created by somebody, put it on the web, on GitHub as an open source project, but that was before TypeScript was very popular, or the guy is just not interested into TypeScript. And when you want to import that library to your project, it gets a bit tricky because like everything would be assigned to the any variable. So you lose all the functionality of your IDE helping you to complete the code, allows you to identify errors or typos. So it's not very useful. But what we can do is when we import them, we can declare ambient structure that represent basically the model of that library. So if we take the example of TypeScript, well, if we didn't have I said TypeScript. I meant jQuery. If you were to import jQuery, and there was some time, actually jQuery changed frequently enough to not have the TypeScript equivalent or definition fresh enough. You needed to kind of patch it yourself. So what we use is declaring the structure of what is jQuery. We would basically create some form of interface form where we say jQuery have a method for the onReady, all the popular selectors, and so on that you use, the val, HTML, text, the on event, these things. You don't want to rewrite the whole thing, but you can extract basically just the model of these properties and say, okay, jQuery, this is the way it works. Now I reference this file to my code, and I can just use it as a feature without needing to worry that it is TypeScript or not. We will have an exercise in the first project or second project later this afternoon to play with that. And we have let and const. So if you're familiar with ES6 also, I'm not sure ES5 already have const, but basically the main difference between let and const is const cannot be reassigned. Once you define it, then it's done. You cannot assign a new value to it. So we're talking object. We can consider TypeScript to be an object-oriented language. It supports a lot of these features. So we can argue that it is really the case, but we can use a lot of features such as classes, interface, abstract content, and all these features that we find in those popular language. And we can build from there any other features that we find in C#, Scala, Java. There will be a workshop, an advanced workshop, or a more complete for advanced properties in 1 or 2 months from now, where we will go deeper into like generic types and all those extended features that we can use. But today, I don't think we will have time to go through this aspect. But if you have questions, if you're curious about it, we can talk about it at the break in about 30 minutes or so, and we can have a quick chat about it. So an object have properties, obviously, and there is actually properties as defined again in ES6. I think it is also introduced in ES6. I'm not sure it's in ES5 too. Have you used getter and setters in JavaScript? Yeah, so we find this kind of natively also in TypeScript. The good thing with TypeScript is that when it transpiles, we can set to which language it's going to be transpiled to. By default, it will go to ES3, which basically even IE5 supports. Well, maybe not IE5, but like very old IE can support this JavaScript. But that means it's going to transform unsupported features by rewriting or recreating JavaScript to fill the gap. Or if it is really an old browser or an old version of Emacs script, it just won't be able to do that, and the feature will not exist. And that's the case for getter and setter. In some version of transpilation, it will not work. So use it if you know that your consumers or your clients have recent browsers. But I think most of us are having customers or users that are at least on like a recent version of IE, and other browsers are usually fine. So we have variables. We went through the different types of variables we can find. Constructor, so this is same again as an object-oriented programming language. Literals, so literals is where you define an object by only assigning properties. I think there is an example later, otherwise we can play with it during the workshop as well. And index. Index is actually kind of an advanced type of property where you define what is the format that you can set, or the data type that you want to allow in your object. I don't have in those slides the example. Again, during the workshop, if you're interested, or just Google for it to find some way to play with it, but it's rarely used. It's not very common in regular application. This is more useful when you want to create libraries, and that will be part of a workshop in the next advanced TypeScript workshop. So I talked about class. Class are a specific type of object. I think everybody here is familiar with class. Anyone is not familiar with class? This is not CSS class, just to make sure, right? Okay. So a class basically is the object that holds your properties, your variables, your methods, and you can use and compose them to build your application in a more organized fashion, right? We have members that can be public, private, protected, abstract, read-only, static. So this is also terms that you should be familiar with, not in JavaScript, but in other, not necessarily in JavaScript, but in other languages. And we use them usually the same way. A quick note about these modifiers. We are not going to spend too much time into namespacing and modules. If at the end of the workshop we still have time, we could eventually start to play with it, but it's not focused for today. And therefore, the private and protected modifier will not be extensively used today. The same way, we can extend classes. So we can compose, as I was saying, or extend the features, the functionalities of a class. And we can have abstract classes. We will not do specific case of abstract class. There's much more interesting things to play with today. So I think we need to look at some code, because I do have some example for the classes. Okay, so actually this is not the right version of the repository. We should have some classes, some car and some sports car. Okay, then after the break maybe we will have a look, but that's strange. The TypeScript initiation. Sorry to take a few minutes, seems like something is missing. Course. Okay, so we will not have it here, and that's fine. We can, after the break, I will re-upload, and we can play as the workshop. Okay, so in ES6 again, we have also the fat-arrow functions or the Lambda function that are available. It is also here in TypeScript. Do you know what are the main functionalities of, well, it's already there, so you actually can cheat here, but what are the main reasons or the main use case we can have with Lambda functions? Don't look at the screen. Okay, so basically, one interesting thing is like it captures the this keyword. We all met these problems where we expect to use like this.name. In my previous example, I think it didn't work very well actually for that one. And we get the this of something that is coming from another function, another scope, so it's often undefined. The thing is that when we use the Lambda function, it will be automatically capturing the this keywords, but that could hit you indirectly if you don't pay attention how you apply that. If your function is a callback, you might probably not want to use the Lambda expression, because actually, yeah, I didn't put the reason why, so can somebody tell me or guess why we cannot use the proper reference to this when we use Lambda expression in a callback? Any guess? Yes, exactly. So you would be in the context of the call that actually, of a code that is in the call, that is calling the callback. So if it is in jQuery, you or in a timeout, you would be in the context of a timeout method, and the this would be basically undefined, most likely. So this is where you need to be careful. So don't overuse of Lambda. It's not like your standard notation to use. It looks cool, like when you put Lambda here and there, like it looks kind of an advanced feature, but use it only when you need it. And okay, so we'll go after to this one. REST parameters. So this is also comparable to what we find in other languages, where you can assign, like, this notation allows you to pass a list or an array of values, and then it will just add it to the as a form of array. We have the spread operator that is kind of using the same functionality as REST parameter, where you can map. Oh, it's not extended. Yes, so you have this example here of the REST parameter. You have an array of functions, and here you can access directly to this property inside the methods as you go. You don't need to refer as a form of array. Now, if we look at this code, can you see at the back the code? Yeah. Can somebody tell me what is wrong here? Let me move the mouse. Anyone? Yeah, let you read. It's more an error or something that is not appropriate to do. It's not really a mistake. That would work fine. Correct. That's the first one. There's more. Sorry? No, but it's fine. You don't have to declare the type, but you can precise, like actually, you're kind of on the direction where we are just putting like void, where it's not like useful to do that, because when you use those methods, the IntelliSense would tell you that it returns void, right? It looks good if you want to illustrate examples in your, or document your code on a real application. You probably don't want to do that. But you're not far. Well, that's fine, because we have, oh, I don't think I can jump here. We have the Lambda function, so this scope is correct. I'm sorry? Well, if you do that, you would lose the scope of this. But that's getting warmer. Like, that's really very close. I'm sorry? Not necessarily. Which is fine, because private is inside the class. Private only constrains the field inside the class. Don't try to extrapolate from what I mentioned earlier. I actually said what we shouldn't do before. So it's coming from what the last 5-10 minutes that I've been sharing some. Where? So that's actually the other way around. If you use this, you want to make sure you are in the scope of your function, but then you cannot use start, or you shouldn't use start in a callback. However, stop and honk, you're not using this. So why do you need the lambda? Why do you need to capture or to create that extra layer? Just keep it simple. Like, if you don't need the support for this, and you know it's not going to be called by a library, or or you eventually need to get it called via a callback, don't use the lambda expression. So here, these are in particular those 2 points, but you get an extra credit because I don't think, like, it actually compiles. I'm not sure that you need the assign the type this way for the has nitrogen booster. Yes. So the final code would be like this. We remove the lambda on honk and stop, basically. Interface. So interface is also used in the same context as what we do in object-oriented programming languages. You can define interface as a blueprint for a functionality of your code and apply it to a variety of classes or other interface. You can extend an interface with another interface to augment the functionality. And it's interesting also as a data object to use interface. So basically, when you create an interface as a data object, it only provides functionality for your coding. Because when it's transpiled, it just disappears. Because JavaScript doesn't have interface, right? So you need to transpile it to something that doesn't exist. You basically remove it. I have an example here for a car, or in the context of car equipment. So we have an interface audio system that has a name and the power of that audio system. We have an interface equipment that contain the structure of the audio system, has GPS, have airbags, and then an iVehicle interface that has the start and stop method. So when we use new car here and we implement iVehicle, so I am declaring that I want the car to implement the interface iVehicle. Now we are compatible because we have the start and stop method. The honk is not there, but we don't really need it here. This is how it is compiled to, transpiled to, well, which is the same. This is the JavaScript that has been generated from all those three interfaces and the car. Can we see the interface there? There is no audio system interface. There is no other unused properties. So TypeScript doesn't include or doesn't transpile what is not needed. It's really optimized in such a way that only the properties and the code that is needed is transpiled and converted. Now, if we were to actually assign the audio system to the car, it would be just a member with the case any, the property any in JavaScript, right? But it would exist only in the context of TypeScript. And it's useful to write code because you want to have those interfaces to play with data model, to transfer via JSON, or to retrieve from an API endpoint and get model as an interface. But in JavaScript, you don't need that extra layer, so it's just removed. We have some additional topics just to share a few concepts that exist also. We can cast objects to different types. So when we have interface, sometimes we need to, or we extend classes, we need to cast to the right format, otherwise TypeScript would complain. We have generic. We will not play with generic today, but that's the similar notation to what you might already know in other types of languages. Destructuring. So we have again our RGB format. So here I'm creating an object literal. I was talking about that earlier. We have an object literal here that has three members, R, G, and B, and I assign it to the RGB property. And now I'm going to destructure it to the three variables R, G, and B. And I just need to assign it to with that notation, and I can use RGB independently. If you are familiar with PHP, there is something very similar where you can destructure with a list, or I don't remember what's the keyword, where you can transform an array or list to individual properties. So it's very close to that. And then we have template strings. It is useful, but it can be also dangerous because then you need to make sure you control what is in your template. And if something changes, if you have functions, like you could have mathematical operation here, you could put like calculate something, you can have 5 plus 2. That can hide something because it's interpreted at runtime. We go back to the JavaScript type of risk where you don't know exactly what's going to happen when it runs, right? But if you wanted to use a template, if you wanted to create your own template engine, for example, either for fun or for actual practice, this is the way that you would do. So the property name here, the variable name, is inserted here and interpreted to John Smith. So you can use that, but again, it's not so advised to use too much unless you are actually writing specific libraries for that. Whereas there are much better tools or much better way to do that kind of formatting by using popular libraries from as simple as a Vue or other framework, but you can go with React, Knockout, Angular, that will allow you to do something a bit more strong. Some other things, so I was talking about properties. We have for each. Like that's a pain to use in JavaScript, right? Because when you do for each, you actually get a reference to the index, and then you need to access the array at the index that you get for the for loop. Here you only do for ID of ID list, assuming ID list is an array or an actual list, and ID will contain directly the value of your property. So it's just like less cumbersome to use. And I mentioned earlier, we can extend classes. So just to look at how setter and getter property look like, I changed the has nitrogen booster. I added a setter and a getter. So how does it look like? Can you find out how a getter or setter method look different from a regular function? So there is the prefix, yes. It's not necessarily very visible here because we could omit it. But one thing is that on the setter, because you can only assign a value, there is no return type. So if you try to do like a colon void, for example, because it returns nothing, it would actually not be a valid code. So you cannot have a return type for a setter. And you, in the same way, you cannot have a value to be passed in a getter. You can only assign it through the getter, sorry. You cannot pass a value to a getter. Here, the way I'm using it is from the constructor. I want to add some logic about my nitrogen engine or booster. And the way I'm using the setter is, let's use the mouse because I'm not tall enough to reach over there. So here, you see I'm really assigning the property to not a function, right? It looks like I'm just assigning it to another property. And that's how, so it's different to allocate or to assign a value to a getter. And when you want to use the getter, basically you would use the same notation and use it and assign it in the other way. And this is how I can extend my class. So earlier we have a class car with all those property, and I can create a sports car. And in that occurrence here, I am, where's the mouse? Here. I'm setting a default for the constructor. So I can call the super constructor, and everything else will be inherited from that, from the car in the workshop. If after I push the updated version, you will be able to recreate that code. So don't take picture because you're going to have to create those things. Now, before we start the actual workshop, I think we can take a little break. But if you don't have this on your machine, then that's the perfect time to do it. If you have questions also, we can, I can take a few questions if you have, and we can reconvey in about maybe 10 minutes. Do you need more? Not yet. Usually stop.